Hello student, today we are going to learn units and measurement for part 1 video, okay. So I am going to do with full class 11, okay. Every day 10 a.m. we have a class 11 video I am going to post, okay. We are going to learn units and measurement for part 1 video, okay. So I am going to do with full class 11, okay. Every day 10 a.m. we have a class 11 video I am going to post, okay. Yeah, first I will be introducing what is physical quantity, okay. So physical quantity, physical quantity, it is will be always have with number with magnitude with unit, okay. The physical quantity it's going to be have magnitude with unit, SI unit, okay. With units will be there, that we can take it as a physical quantity, okay. If example, we'll take it as a 5 Newton, okay. 5 is magnitude, Newton is the unit. This we can call it as a physical quantity, okay. Next, see, there are different types of unit is there, okay. MKS, it is CGS and FPS, okay. 3 different unit we have. MKS, meter kilogram second, CGS, centimeter gram second, okay. Then FPS, foot pound second, okay. So out of these 3, MKS will be taken as a SI unit. This we are taken as a SI unit, okay. Because it is easy to handle, convenient and easy to convert, okay. Many advantage we have for SI unit, okay. Meter kilogram second. Hereafter, whatever you are doing problem, you should follow with the MKS system, okay. That's going to be the follow is a SI unit, which is going to be called meter kilogram second, okay. So which is called as the SI unit, okay. Hereafter, whatever problem you are doing, you should do with the MKS system, that's going to be meter kilogram second, okay. Now we'll be seeing with what is quantities. There are 2 types of quantities is there, fundamental quantities and derived quantities. The advantage of SI system, because it's convenient shape, size and easily we can convert one unit to another unit, many advantages there for SI unit, okay. Now quantities, there are 2 types of quantities is there. There are 2 types of quantities is there. One is the fundamental quantity. Fundamental quantity. The another one is the derived quantity. Okay, fundamental quantity and derived quantity. There are 2 types of quantities is there, okay. Fundamental quantity, there are 7 fundamental quantities is there. Length, mass, time, temperature, current, okay. It is mole of substance, amount of substance also we can call, or mole of substance, amount of substance also we can call. Candela, candela will be the light intensity. These are the 7 fundamental quantities. Other than this, everything will be the derived quantity. It is a fundamental quantity. 7 fundamental quantities we have: length, mass, time, temperature, current, mole of substance, candela, okay. Derived quantity, derived unit also we can say, okay. Other than this, everything will be the derived unit. What is a derived unit? Example, okay. Other than this fundamental quantity, everything is a derived quantity, okay. Fundamental quantity, say it's a independent quantity, it's not depend on any other quantity, but derived quantity is depend on the fundamental quantity, okay. Derived quantity is depend on the 2 or more than one quantities of fundamental, we can call it as a derived quantity. If example, area is length into breadth, it's depend on 2 fundamental quantity, okay. So that's going to be derived quantity. We'll take it as a density. Density is equal to mass per unit volume, okay. So it's depend on the 2 fundamental quantity, which we can take it as a derived quantity. Okay, so which is not depend any other thing, we can take it as a fundamental. That's coming under this 7 category. Okay, other than this, everything will be the derived quantity. Example, density, velocity, force, many things we can take it. Okay, acceleration is equal to velocity by time. Density, force is equal to mass into acceleration. Is other than this 7, we can take it, everything is the derived quantity. There are two types of quantities is there. One is a fundamental quantity, another is a derived quantity. There are two quantities we have. Okay, now we are going to do with the fundamental units. Okay, dimensional unit, that's the thing first you should know. When you are coming for the 11th standard, you should know what is a derived quantity and what is a unit of derived quantity, SI unit and dimensional formula for the derived quantity. Okay, first chapter is fully there, SI unit and dimensional formula. Okay, yeah. Now, fundamental quantity is an independent quantity, derived quantity is a dependent quantity. Now, I'll be introducing with what is dimensional formula. Okay. So length, first we will take it fundamental quantity unit. If you know fundamental quantity, easily you can do with the derived quantity, because derived quantities depend on the fundamental quantity. For length, okay, SI unit, always you should follow SI unit. SI unit is a meter, kilogram, second. Okay, for length, unit SI unit is going to meter. The dimensional formula, if you want L, you can write. Okay, length it's for L. The next one, it is M is for mass. The unit of mass is going to be the kg. Dimensional formula is going to be M. Okay, you should take it. The dimensional formula of mass is going to be the M. The next one, time. Time we can take it unit of second, because meter, kilogram, second. Okay, the dimensional formula we can take it as a T. Okay, next, current. Current unit we can have ampere. The dimensional formula also ampere. Okay, so this is the unit we have to give for the dimensional also. Okay, candela and remaining thing, temperature, this everything we have individual. Okay, so it's example, candela means directly you can write as a candela. Okay, which is the intensity of the light, we can take it as a candela. Okay, the another thing, mole of substance, amount of substance. Okay, we can take it as a mole. Amount of substance we can take it as a mole. Okay, the next one, temperature. So when we are taking as a temperature, usually mostly we have to follow as the Kelvin. Okay, sometimes we can use degree Celsius also. Okay, don't use as a Fahrenheit. Okay, only these two cases we can use. Yeah. Now I am going to do it dimensional formula for different physical quantities, different unit, whether it's a fundamental or derived. We are going to learn dimensional formula for all the units, all the formulas. Okay. Yeah, tomorrow class will be doing with the errors. Okay, so every day we have the class for 11th standard. Every day 10 a.m. I'm going to give the class for 11th. Okay, most of the days 10 a.m. I'll be start with the class 11. Okay, yeah, most of the day we are going to 11th at 10 a.m. Okay, now first is the area. What is the formula for area? Area is equal to length into breadth. Okay, length into breadth. I'm doing very fundamental. Okay. How we can measure with the length? Length is going to be, its 12th is mostly we'll be doing with 9 a.m. Okay, so already I am doing with 12th also. Length, area is equal to length into breadth. Okay, so length is meter, breadth is meter. We can have meter square. The unit of area is going to be the meter square. What about the dimensional formula? Dimensional formula we can take it as a L. Okay, because length we can measure as a L, because it is L square will come. Okay, it is a SI unit and this is the dimensional formula. Next we are going to do with the volume. First I will be introducing with all the formulas which is we are going to find as a dimensional formula. Okay, so next class I will be increasing with the weightage, but today class we are going to discuss with many formulas based on the unit. Okay, now so we are going to discuss with the SI unit and dimensional formula both. Okay, next Next we are going to do with the volume. So volume is equal to length into breadth into height. It's going to be meter into meter into meter. We can have meter cube. So dimensional formula will have L cube. Okay. So now we found what is the volume dimensional formula. Okay. Next, displacement. Okay, displacement or distance, anything. Okay, which is measured in a meter. SI unit is meter. Dimensional formula is it is L. Okay, so meter will be taken as the L. Okay, so meter usually will be taken as the L. Okay, so it's look like a very simple, but it's going to be very complex when we are moving the topic. Okay, next. Velocity. Velocity is equal to displacement by time. What is the unit of displacement? Meter. Time is second. So we'll have meter by second. From denominator, if you are taken a second as a numerator, second inverse. So the same unit we have meter second minus 1. Okay, what about the dimensional formula? It's going to be m power. Mass is not there. Power 0. Length power 1. Time power minus 1. So I got velocity dimensional formula. Okay, and yes, a unit also. The next one, acceleration. Acceleration is equal to velocity by time. What is the velocity? Velocity is meter per second. What is time? Second. So we'll have meter by second square. Okay, we'll have meter by second square. From denominator, if you are taken second square as the numerator, we'll get as second minus 2. Second minus 2. What about the dimensional formula? So m power 0, there is no mass here. Length, mass is going to be length. Okay, sorry, meter is going to be the length, time is going to be t minus 2. So I got now what is the acceleration dimensional formula. Okay, next we are going to do with the force. Force is equal to mass into acceleration. Mass is how much? Mass unit is going to be, mass usually we should be measuring with kg. Why it's not a gram? Always you should follow as a MK system, meter, kilogram, second. Okay. So mass, acceleration we will have meter by second square. Okay. Already we did acceleration. Second, if you are taken as a numerator, we'll have second inverse. Okay. So we'll have kg meter second minus 2. What about the dimensional formula? Mass is m, length is L, time is t power minus 2. It is a final SI unit of force, and it is a SI unit of a dimensional formula for force. The another unit of force, we can take it as a Newton also. Okay, if you want solution for Newton, you can do like this. Okay, next, energy, then power. Okay, energy. Okay, next formula will be continuing like this. Energy is equal to force into displacement. We can write the energy is the unit as a joule. Simply you can write it as joules. Now what is joules? We need solution for the joules also. Okay. So 1 joule is how much? So it is force is Newton. 1 joule is equal to force is Newton. Displacement is meter. So we can write as a joules as a Newton meter. Okay. We know already what is Newton. Newton is kg meter second minus 2. Already we found here. Into meter. So meter will have meter square. So kg meter square second minus 2. It is called 1 joules unit. Now what is the dimensional formula for 1 joules? Okay. So it is m, mass is m, length is L, time is t, L square t minus 2. So it is the dimensional formula for energy. Okay. Next we are going to do with power. Power is equal to energy by time. Simply forgot about the formula. I think you are in 11th standard, you don't know any of the formulas because you are now only it started. Okay, so forgot about the formulas. This is the formulas you are going to learn 11th and 12th together. Okay, only you should focus how to find the dimensional formula. That's alone it's required for this stage. Okay, no need to bother about the formulas. Okay, so they will be asking the question the formula based on which you know already. Okay. Next, energy. Energy we completed. Next, power. Power unit will be taken as a watt. So power is equal to energy by time. Okay, power is equal to energy by time. What is the energy unit? So energy unit, it's Newton meter. We can write as the joules per second also, which is called power, which is going to be power. It's going to be watt. The power unit is going to be the watt. Watts also we can take it. Joules will be Newton meter. Time is going to be the second. Okay, like this we can write as the power unit. Okay, what is Newton? Already we know what is Newton. Newton is kg meter second minus 2 into meter divided by second plus 1. If you are taken second from denominator to numerator, we'll get as a second minus 1. Okay, so second minus 1 will get. So we'll have kg meter will have meter square second minus 2 second minus 1. The answer I'll get second minus 3. Okay, so we'll have the unit of kg meter square second minus 3. Now what about the dimensional formula for power? Okay, so m power 1, L power 2, T power minus 3. Now I got what is dimensional formula for the power also. Okay, now the next thing we are going to do with a continuation of thing, we have many formulas to find the SI unit and dimensional formula. Okay, this is the main unit. You have to know all the formulas based on fully 11 and 12. Okay, then we are going to learn each chapter separately how to find the dimensional formula and the SI unit. Okay, now I'll be taken with density. Okay, some of the formulas you know, some of the formulas you don't know. Okay, totally you are going to learn when you are going to the 11 and 12. Each concept we have many formulas. Okay, so now density is equal to mass per unit volume. Okay, now what is the unit of mass? Mass unit is going to be kg. Okay, mass unit is going to be the kg. What about the volume? Volume is going to be length into breadth into height, which is going to be called as a meter cube. From denominator, if you are taken as numerator, meter cube as a meter minus 3. So we'll get kg meter minus 3. Now what is the dimensional formula? Already I told you mass is m power 1, length is not there, length is power minus 3, time is not there, power 0. Okay, like that you can give with the dimensional formula. Next one we are going to do with the momentum. Okay, momentum is equal to mass into velocity. So momentum is equal to mass into velocity. What is mass unit? Mass unit is a kg. Okay, so mass unit is kg. Velocity is meter per second. From denominator, if you are taken a second as a numerator, second minus 1 will come. So kg meter second minus 1. The dimensional formula m power 1, L power 1, T power minus 1. Okay, this is the dimensional formula for momentum also. Okay, now we learned what is the dimensional formula for momentum. Okay, next is pressure. Pressure is equal to force per unit area. What is force? Force unit is going to be the Newton, area unit is going to be the meter square, which already we know. Okay, it's going to be the Newton by meter square, or equal to pascals also we can take it, because pressure unit is going to be the pascals. If you are taken as a meter square as the numerator, we'll have meter minus 2. Okay, so the pressure unit we are going to get Newton meter minus 2. What about the Newton? Newton is kg meter second minus 2 meter minus 2. Okay, this plus 1, that is minus 2. What is the answer for it? Okay, so kg meter minus 1 second minus 2, because plus 1 minus 2 will be minus 1. Now dimensional formula for pressure m power 1, L power minus 1, T power minus 2. Now I got the dimensional formula for pressure also. Okay, then
the world is changing so quickly today.
Yeah. Now we'll be continuing with the value or with the formulas. Okay. Okay, next we'll do with the its dimensional formula for rotation motion. Okay, so what I'll be getting for rotation motion? So the first one, angular displacement. Angular displacement will take it as a theta. Okay, so angular displacement will be taken as a theta. Okay, theta will be a radian. Okay, the theta will be measured in a degree. Degree is going to be the radian. Okay, so radian. Radian we don't have dimensional formula. M power 0, L power 0, T power 0. Okay, there is no dimensional formula for radian. Okay, the next one, angular velocity. Angular velocity is going to be angular displacement by time. So you can write like this, or theta by t. What is theta? Angular displacement. Angular displacement is called, it is a radian. Radian by second. Okay, so radian already said it's not having dimensional formula. So if you are taking a second as a numerator, so radian second minus 1. Now what about the dimensional formula? M power 0, mass is not there, length is not there, time minus 1. It is a dimensional formula for angular velocity. Okay, next, angular acceleration. Angular acceleration is angular velocity by time. Okay, angular velocity already I told you it's a radian per time. Radian per time divided by time. So rad per second square. It is angular acceleration. From denominator second square, if you are taken as a numerator, second minus 2 will get. Okay, so we'll have radian second minus 2. What about the dimensional formula for angular acceleration? So m power 1, m power 0, L power 0, T power minus 2. It is for the dimensional formula for angular acceleration. I already told you, forgot about the formula, only focus about the how to find the dimensional formula. In class 11, you don't know many of the formulas, only you will focus how to find the solution, and then only focus what you know already. Okay, so mostly the question will be asked from 11th, that's the formulas which you learned, that only they will be asking, okay, in your exam. So angular acceleration I learned. Okay, next, torque. Torque is equal to force into perpendicular distance. What is force? It's a Newton. Perpendicular distance is meter. Okay, so it's same as the energy unit. Okay, so Newton we can write as a kg meter second minus 2 into meter. Meter will have meter square. Okay, so we'll have kg meter square second minus 2. So what about the dimension formula? M power 1, L power 2, T power minus 2. Okay, it is the torque dimensional formula. Okay, yeah, just a minute, I'll come back. Okay. Next, stress is equal to force per unit area, which is equal to the pressure unit. Okay, stress is equal to force per unit area. What is the force? Force is a Newton, area is a meter square, so we can have Newton by meter square. Stress formula, force per unit area, which we are going to learn in 11th standard. Okay, if you are taken meter as a numerator, we will have Newton meter minus 2, which is going to be kg. Newton already we know, kg meter second minus 2 meter minus 2, it is plus 1, that is minus 2, so kg meter minus 1 second minus 2. Now what is the dimensional formula for stress? Stress is equal to it is m for mass, length for L, and time for t power minus 2. It is a stress dimensional formula. Okay, next one is a strain. Okay, so this all the formulas we are going to learn for upcoming days. Okay, the next one, strain. Strain is force per changing length by original length. Okay, actually this formula will call changing dimensional by original dimension. Okay, now what is a changing dimension? It's a length by original length. Okay, changing length we can take it as a meter. Original length also will be taken as meter. Meter get cancelled. The no unit. Okay, whether it is a SI unit or dimensional formula. We don't have dimensional formula. No dimensional formula. Okay. The next one, refractive index, which we learned in 10th standard. Okay, so refractive index is equal to speed of the light in a air medium and speed of the light in a speed of the light in a glass. Okay, refractive index will be the ratio of the velocity. Okay, it is meter per second and meter per second. Okay, we don't have unit for this. No unit and no dimensional formula. Okay, so stress also we don't have dimensional formula, and refractive index also we don't have dimensional formula. Okay, next we are going to do with the this stress we learned. Okay, modulus of elasticity. Okay, a modulus of elasticity is a stress by strain. Young's modulus, bulk modulus, rigidity modulus, any modulus. Modulus of elasticity is going to be stress by strain. Okay, stress by strain. What is stress? Stress is going to be force per unit area. What is strain? It can be three types of modulus of elasticity is there. Okay, you can learn only one thing, Young's modulus. Okay, remaining modulus you can learn when the concept is coming. Okay, so it's changing length by original length. Okay, so it's going to be Newton by meter square divided by meter get cancelled. Okay, it's same as the strain, Newton by meter square. If you are taken from denominator to numerator, Newton meter minus 2. Okay. Now we are learning what is a modulus of elasticity dimensional formula. Okay, Newton is kg meter second minus 2 into meter minus 2. So when we are doing this, kg meter minus 1 second minus 2. So dimensional formula m power 1 l power minus 1 t power minus 2. We got dimensional formula for modulus of elasticity. Okay, next. Surface tension. Surface tension is going to be force per unit area. Okay, surface tension is going to be force per unit length. So force per unit length. What is force unit? Force unit is a Newton and length unit is a meter. So Newton per meter. The correct unit we can write as surface tension is a Newton per meter. Okay, now we are finding what is the dimensional formula. Okay, so dimensional formula for this, Newton is kg meter second minus 2 divided by meter. Meter get cancelled. Okay, only the kg second minus 2 will be there. Okay, so the dimensional formula is going to be m power 1 l power 0 t power minus 2. Now I got surface tension dimensional formula. Okay, now we are solving all the dimensional formulas based on the 11 and 12, all the topics we are doing. Okay, now so for you know in 11th standard you no need to bother about the formulas where you are getting. Okay, only you have to focus how to find the dimensional formula and SI unit. Okay, in upcoming days you will be learning all the formulas, how it's going to come. Okay, the first chapter is going to be related with all the chapters SI unit and dimensional formulas. Okay, now stress, strain, okay, angular momentum. Then I am going to do with the unit which is based from the electricity, current electricity. Okay, So current, electricity, ampere we should relate. Okay, that also we are going to learn now. This and all is from the units from 12th standard. Okay. So only you learn how to do. That's it. That's much is enough in 11th standard. Okay. So the first one, current. Current unit is going to be the ampere. Dimensional formula is also ampere. What about m power 0, l power 0, t power 0? Only current power plus 1 will be there. Okay. The next one, charge. Charge is the current is equal to charge by time. If you want charge, charge is equal to current into time. Okay. Now what about the dimensional formula? Current is ampere, time is a second. Okay. Now dimensional formula is going to be m is not there, l is not there, but time is there plus 1. And ampere also is there plus 1. Okay. One thing I want to represent. Whenever you are giving the dimensional formula, you can give maximum 4 terms. Okay. One is m, another one is l, another one is t. The another one, fourth one is going to be the current, ampere. Okay. Otherwise the fourth term can be temperature or mole. Okay, like that. Okay. You have to give based on this are the concepts. Okay. Now I given what is the dimensional formula for current. Okay. The next one, voltage. Voltage is equal to work done per unit charge. Work done is a joules, which is going to call as a Newton meter. Okay, work done is going to be joules and charge is going to be the coulombs. Okay, so joules we can write as a Newton meter. Joules we can write as a Newton meter. Okay, then coulombs from denominator to numerator we can take it coulombs inverse. Okay, so we know already coulombs we don't have dimensional formula. So instead of writing coulombs you can write as a ampere into second. Okay, so coulombs, 1 coulombs is equal to ampere into second. That right here. So Newton is kg meter second minus 2 into meter, coulombs is the ampere into second minus 1. Okay, now we are doing solutions for voltage, SI unit and dimensional formula. Okay, so we can write meter square, so kg meter square second minus 3, because this minus 1 I am bringing as a inside. Okay, ampere inverse second inverse, so this together will become a second minus 3. Okay, so now kg meter square second minus 3 ampere inverse. Okay, what about the dimensional formula? M power 1, L power 2, T power minus 3, A inverse. This is a dimensional formula for voltage. Okay, next one we are going to do with the resistance. Okay, so resistance is equal to R is equal to, according to Ohm's law, R is equal to V divided by I. Voltage we found already. Okay, if you want you can calculate one more time also. Voltage is work done per unit charge joule per coulombs. Okay, coulombs we have to convert into ampere into second, because coulombs we don't have dimensional formula. Okay, voltage already we found. This is the final unit of voltage, kg meter square second minus 3 ampere inverse. It is for voltage. Okay, current is ampere. From denominator if you are taken current as a numerator, which will get ampere minus 2 or minus 1 will become as minus 2. This is going to be plus 1. If you are taken as numerator, it will become as a minus 1. Okay, so we'll have resistance unit is going to be kg meter square second minus 3 ampere minus 1 ampere minus 1 minus 1 is going to become as minus 2. So the unit we are going to get kg meter square second minus 3 ampere minus 2. Dimension formula, m power 1, l power 2, t power minus 3, a power minus 2. I got now the resistance dimensional formula. Okay, next we are going to do with electric field. Electric field is the force per unit charge. Okay, now we are learning dimensional formula. It's based on from 11th and 12th together. Okay, it is from class 11. Okay, in 11th standard you don't know many of the formulas. I know that one. Okay, only you need to know how to solve the solution. That's it. Okay, next one, electric field. Electric field you can calculate and tell me what is that electric field. Electric field is equal to force per unit charge. Find the dimensional formula and tell me. electric field is equal to force per unit charge. Okay, it's very simple. Force unit already we know it is Newton. Okay, a force per unit charge. Yeah, then charge unit is the coulomb. So Newton per coulombs. Okay, so what is Newton? Newton is kg meter second minus 2. Then ampere from denominator we can take, coulombs we can take it from denominator to numerator. Coulombs inverse we can get. Okay, then we'll have this unit is going to be kg meter second minus 2. We know already coulombs, we don't have dimensional formula. Coulombs we can write ampere into second, inverse of this. Okay, so kg meter second minus 2 ampere inverse second inverse. Okay, so finally we'll get kg meter second minus 3 ampere inverse. What about the dimensional formula? So we can write dimensional formula m power 1, l power 1, t power minus 3, a power minus 1. This is a dimensional formula for electric field. Okay, the next one, magnetic field. Magnetic field we can have B. Okay, it's going to be the Tesla. Okay, so we are going to find what is the SI unit and dimensional formula for magnetic field, which is called as the Tesla. Okay, so B magnetic field is equal to dash. So what is the SI unit and dimensional formula for magnetic field? Okay. So according to Lorentz force, in 10th standard also we learned F is equal to IBL. Okay, we want magnetic field which is going to call us the Tesla. B we want. B is equal to F divided by IL. What is F? F is the Newton. What is I? Ampere. Length is the meter. So Newton by ampere into meter we can have magnetic field unit. Okay. So Newton is kg meter second minus 2 divided by ampere into meter. Meter get cancelled. Ampere from denominator to numerator I will take. Okay, the unit of this one we are going to get kg. It is meter power 0. Okay, second minus 2 ampere inverse. So dimensional formula m power 1, l power 0, t power minus 2, a power minus 1. So this is a dimensional formula for magnetic field. Okay. So now we are measuring with, now we are finding with all the unit, SI unit and dimensional formula. Okay. Next one, moment of inertia. In rotation motion, moment of inertia, angular momentum also is there. Okay. So electricity, rotation motion, all the formulas we are measuring. What is SI unit and dimensional formula? We are going to do with constant values also. Okay. So we have inertia, moment of inertia, mass into radius square. Mass unit is kg. Radius unit is going to be the meter because of square will be meter square. So dimensional formula m power 1, l power 2, t power 0. Okay, dimensional formula for moment of inertia. Okay, the next one, dimensional formula for angular momentum. Angular momentum is equal to linear momentum into radius. What is linear momentum? Linear momentum is kg. Linear momentum is mass into velocity, I into radius. Mass is, what is mass? Kg. Velocity is meter per second. What is distance? Meter. Radius is meter. Meter we can write as a meter square. So we'll have unit kg meter square. Okay, second from denominator I am taken as numerator, second minus 1. So what about the dimensional formula for angular momentum? M power 1, L power 2, T power minus 1. So I got dimensional formula for angular momentum also. Okay, next formula we are going to do with the mass density. Okay, mass density, mass per unit volume, energy density. Okay, so energy density. So energy density is very simple. Energy density is very simple. It is energy per unit volume. Okay, so energy is a joules, volume is a meter length into breadth into height, which is going to call as a meter cube. So joules per meter cube. Okay, from denominator this if you are taken as numerator, joule meter minus 3. What is joules? Already I told you it is Newton meter. Okay, so it is Newton meter into meter minus 3. Now we are going to calculate what is the dimensional formula for energy density. Newton is kg meter second minus 2 into meter minus 3. So this all the meter if you are making together, kg meter plus 2 minus 3 will get, because this is square and minus 3 will be there, second minus 2. What is the solution for this? We'll have kg meter minus 1 second minus 2. So dimensional formula for this, m power 1, l power minus 1, t power minus 2. It is for energy density. Okay, next we are going to do with the all the constant also. Okay, in this class we are discussing a dimensional formula and SI unit of all the all the units. Okay, all the formulas, physical quantities. Okay, fundamental quantities already we know. We are solving now. It is a derived quantity. Okay, which is depend on the fundamental quantity. Okay, next one, electric flux. Electric flux. Electric flux symbol we can write like this, which is going to be electric field into area. Okay, actually this unit we can call as the Weber. Okay, the unit of flux will be Weber. Electric field is force per unit charge. So force per unit charge into area. Force is Newton, charge is coulombs, area is meter square. Okay, so Newton by coulombs into meter square. Now we should do solution for this, which is we are finding as the electric flux. Electric flux is equal to electric field into area. If you want electric field, already we did electric field. Okay, now so kg, Newton is kg, meter second minus 2 into meter square. Coulombs from denominator I am taking numerator, coulombs inverse will give. Okay, so meter square will have meter cube, kg, meter cube, second minus 2. Okay, because this is electric field and this is area. Okay, now coulombs inverse usually we have to write ampere into second. Coulombs we should write as the ampere into second, which is the noun only. Okay, so now kg, meter cube, second minus 2, ampere inverse, second inverse. Now you should do with the solution. Okay, what is the solution I can get? Kg, meter cube, second minus 3, ampere inverse. Okay, now dimensional formula. M power 1, L power 3, T power minus 3, A inverse. Okay, now I got dimensional formula for electric flux. Okay, then we are going to do with the dimensional formula for magnetic flux. Magnetic flux. So totally we can call this unit as a Weber. Okay, this also flux will be Weber. Okay, so flux is equal to magnetic field into area. So which is called Weber. Flux will be Weber. Magnetic field, okay, formula will be force by current into length. It is from Lorentz force. Okay, into area. So force is Newton, current is ampere, length is meter, area is meter square. Meter power get cancelled. Okay, then we can do with the solution. Now we are learning what is the SI unit and dimension formula for magnetic flux. Okay, now Newton is kg, meter, second minus 2 into meter we have. Denominator ampere is there, that I am bringing as a numerator. So we will get ampere inverse. Okay, now kg, meter square, second minus 2, ampere inverse. Okay, now dimension formula. M power 1, L power 2, T power minus 2, A power minus 1. Okay, next we are going to do with the constant. Okay, before going to that, I will do with charge density. Okay, charge density, there are 3 types of charge density. Okay, lambda, sigma and rho. Okay, so 3 types of values there. Charge per unit length, charge per unit area, charge per unit volume. Okay, it is coulombs per meter, coulombs by meter square and coulombs per meter cube. Okay, there are 3 ways is there for writing the charge density. It's only for line, it is for area, it is for volume. This is formula will be applicable in different situations. So coulombs meter inverse, coulombs meter minus 2, coulombs meter minus 3. Now what is the dimensional formula, that also will be finding here. Okay, see here I am going to do with the dimensional formula for charge density. Coulombs we can write ampere into second. So ampere into second into meter inverse. Okay, dimensional formula. Mass is not there. Length power minus 1, time power plus 1, ampere power plus 1. Okay, next charge density per unit area. Okay, coulombs we can write ampere into second, meter minus 2. Now dimensional formula. M power 0, L power minus 2, T power plus 1, ampere plus 1. Okay, it is a charge density per unit area. Okay, next one, charge density per unit volume. Ampere second meter minus 3. So same, m power 0, l power minus 3, t power plus 1, ampere power plus 1. This is charge density per unit volume. Okay, now we are learning charge density. Okay, then we are going to do with the all the constant term SI unit and dimensional form. Okay, so 2 minutes I'll come and start with all the constants. First constant. Okay, constant terms. Okay, Planck constant we will take it. Okay, energy is equal to Planck constant times of frequency. So if you want Planck constant is equal to energy divided by frequency. Now we are going to calculate what is the dimensional formula for specific constant. 1 minute, I'll come back. Now, we'll be discussing with the Planck constant, SI unit and dimensional formula. Okay, Planck constant is energy by frequency. Okay, you need to know what is frequency. Frequency is equal to 1 by time period. Okay, so here we will be doing frequency unit, then we'll come here. 1 by time period means 1 by second. Okay, from denominator if you have taken second as a numerator, second inverse. Okay, now what is the dimensional formula for frequency? M power 0, L power 0, T power minus 1. It is the dimensional formula for frequency. Actually, now we are calculating what is a Planck constant. Okay, energy unit is joules, frequency unit is 1 by time period. Denominator directly will go into the numerator. Now we are calculating what is a Planck constant, SI unit and dimensional formula. Okay, so we'll have joule second is a Planck constant. So what is joules? Kg meter second minus 2 into meter. It's called Newton meter. Joules is Newton meter. Then into second is that. Okay, so we'll have Newton this much, meter is this much, second is like this. Kg meter square second minus 2 plus 1. We'll have minus 1 finally. Okay, minus 2 plus 1, we'll have minus 1. So kg meter square second minus 1. So dimensional formula m power 1 L2 t power minus 1. So I got dimensional formula for constant is going to be the Planck constant. Okay, the next one, gravitational constant we are going to do. Gravitational constant. Okay, capital G, universal gravitation constant will be taken as a capital G. Okay, this it will take little time to understand. Okay, so capital G. So force, universal gravitation force F is equal to G times of m1 m2 divided by r square. Okay, it is a universal gravitation constant. Okay, G is a universal gravitation constant. I am going to find G dimensional formula. R you can take it numerator, mass you can take it as a denominator. So capital G is equal to Fr square divided by m1 into m2. What is F? Newton. Distance meter, meter square. Mass is kg, kg square. Kg into kg, kg square. So we know Newton already. Kg meter second minus 2 into meter square divided by kg square. So kg square from denominator, if you are taken as numerator, kg minus 2 we can get. Okay, so we'll have kg meter cube, because meter square, meter cube, second minus 2, kg minus 2. Okay, this solution I'll have kg minus 1 meter cube, second minus 2. Now what is the dimensional formula? M power minus 1, L power 3, T power minus 2. So I got dimensional formula for gravitational constant, which is called capital G. Okay. Next one we are going to calculate what is the permeability and permittivity. Okay. So permeability and permittivity. Before going to that, universal gas constant we complete. R value PV is equal to mu RT. Okay. So we know this law. PV is equal to mu RT. Okay. So here R is called universal gas constant. Okay. So PV divided by mu T. Okay. Now P is called what? Pressure. V is called volume. T is called temperature. Okay. Pressure, volume, mu is mole of substance, amount of substance, T is temperature. Okay. So pressure is force per unit area. Volume is length into breadth into height. Okay. Temperature is Kelvin. Mu is the mole. T is temperature. Okay. Newton by meter square into meter cube divided by mole and Kelvin. Okay, like this we can take it. Now we are calculating as the what is the unit of universal gas constant. Okay. So I am taken from basic, very basics, and then I am solving the unit. Okay. So Newton is kg meter second minus 2 divided by meter square into meter cube, whole divided by mole Kelvin. Okay. So now meter cube get cancelled, only one will be there, meter square. So kg meter square second minus 2. From denominator, this if you are taken as numerator, mole inverse Kelvin inverse. Okay. Now what is the dimension formula? Dimension formula m power 1, L power 2, T power minus 2. It's a mole. You can take it right as a mole because it's a fundamental quantity, and Kelvin as the Kelvin. Okay, like that we can write. Okay, it is a universal gas constant. Okay, then we are going to do with the permeability and the permittivity. Okay. Okay, first we'll do with the electric field constant. Okay, so this is formula from 11th standard. 12th standard F is equal to 1 divided by 4 pi epsilon naught Q1 Q2 divided by R square. Okay. So here this is a new term, X term. I introduced with new. This is a charge, this is a distance, this is a force. Everything you know except this new quantity. Okay, that new quantity only we are going to find dimensional formula. Okay, so that is called permittivity. Okay, so this I am going to calculate. See how I am going to calculate. Okay, so epsilon naught is equal to 1 divided by 4 pi force charge by radius, distance. Okay, so now charge is what? Coulombs. Okay, coulombs. We'll have Coulomb square. 4 pi is a constant, we don't have unit. Okay, force is Newton, distance is meter square. Okay, from denominator if you are taken as numerator, Coulomb square, Newton inverse, meter minus 2. Like that we can write. Okay, what is Newton? Newton is Newton is already we know it is going to be kg meter second minus 2. Okay, so it's going to be Newton inverse meter minus 2. Now we should do with the solution. Coulombs also already I said, no need to write as the coulombs you can write as ampere into second into kg. This inverse I am taken inside kg inverse meter inverse second plus 2. Okay, then we have meter minus 2 also we have. Now solution ampere, so it's square, ampere square second square kg inverse meter inverse second plus 2 meter minus 2. Now all seconds together, all meter together. So kg minus 1 meter minus 2 minus 1, and second will be 2 plus 2 ampere square. So unit of this permeability, it's going to be the electric field constant. Okay. So it's going to be m. Mass is m power minus 1. Length is L power minus 2. Sorry, minus 3. Okay, because minus 2 minus 1 minus 3. Time is plus 4. Current is square. Okay, it is a constant it is an electric field constant. Okay, next we are going to do with the magnetic field constant, which is called permittivity. Okay, permeability and permittivity. Okay, permittivity is for electric field constant, permeability is for magnetic field constant. Everything we are going to learn in future. Okay, now we are discussing only the unit. Okay. Now permeability. Okay. Permeability. How we can calculate the permeability? Okay, it is going to call mu naught. Okay. So B is equal to mu naught divided by 4 pi, which is going to be ideal by r square. It is a Biot-Savart law. In 11th standard you don't know about this, but we'll be going to calculate with this unit. Okay, permittivity. Okay, this I am taken this side, this I am taken this side. Okay, so mu naught is equal to B times of 4 pi r square divided by I d l. Okay, this only it's unknown quantity which we are going to find. Okay, B is called magnetic field. Magnetic field is called Tesla. Okay, I'll tell you what is Tesla. 4 pi we don't have unit. Distance is meter square. Current is ampere. Length is meter. Meter square get cancelled. Okay, what is Tesla magnetic field? So F is equal to IBL. B is equal to F divided by IL. Okay, B is equal to F divided by IL. Okay, so this is called Tesla. One Tesla is going to be Newton by ampere into meter. Current is ampere, length is meter, force is Newton. So one Tesla is Newton by ampere into meter divided by ampere. So meter get cancelled. So we'll have Newton by ampere square because meter get cancelled. Okay, so from denominator if you are taken as ampere square as a numerator, we'll get ampere inverse. So Newton ampere minus 2. Newton is kg meter second minus 2 ampere minus 2. The dimensional formula m power 1 L power 1 t power minus 2 a power minus 2. This is a dimensional formula for permeability. Okay. Yeah, next we are going to see the uses of dimensional formula. Okay, what are the way it's going to be used? Okay, the first uses. Okay, there are three main uses is there. First uses, we can identify the equation whether it's correct or wrong. Okay, first I am going to do with the equation how uses of dimensional formula, how we are going to use in concepts. Okay, so the first one to check the homogeneity of the equation. That means to check whether equation is correct or wrong. Okay. We'll be checking the equation. First uses it's going to be used with to identify whether equation is correct or not. So we'll take the equation of motion. V is equal to U plus AT. Now we are doing with uses of dimensional formula. Okay, first uses. To find the homogeneity of the equation. It is velocity, meter per second. Final velocity, it is initial velocity, meter per second. What is this acceleration? Acceleration is meter by second square. Okay, into time is second. Second square get cancelled. Now I am going to apply the dimension formula. Yeah, length, m is length. Time if you are taken as t minus 1. So LT minus 1 plus LT minus 1. Okay, I am telling is the dimensionally is correct. Okay, so this is going to be the correct equation. Okay, you can have one question. Okay, here we have one time LT minus 1. Here we have two times of LT minus 1. Okay, forgot about the magnitude. Only you should find both the side, left hand side and right hand side is equal. Okay, the limitation of the dimension formula, we are not able to find how many times it is. Okay, but only you can prove that dimensionally is correct. That's the thing, you can do it. Okay, The next equation, S is equal to ut plus of at square. Now I am going to find this dimensionally is correct or wrong. Okay, S is displacement L. What is velocity? Meter. We'll take meter. What is the initial velocity? Meter per second. What is time? Second. Second get cancelled. Okay, of is the magnitude. What is acceleration? Meter by second square. What is time? Second. Because of square, second square. So second square get cancelled. I'll get meter is equal to meter plus of times of meter. So L is equal to L plus of L. So this also is dimensionally correct. Okay. The next equation I will be giving. So displacement is equal to H is equal to of GT square. They will be asking some equation they will give. They will ask you whether it's dimensionally correct or wrong. Okay. So H is a height. It is a displacement meter. Okay. Of is the magnitude only. I told already. Magnitude no need to find. Okay. Gravity, acceleration due to gravity, it's going to be meter by second square. Into time will be second square because time is second square. T square will be there. So L of times of L. So it is dimensionally the equation is correct. Okay. So we checked it's this is correct equation. Okay. Next we will do with the little complex equation. That's going to be the wave from the waves. One equation will be given like this. Okay. It's a book back question. See how I am going to use the dimension formula to check the correctness. Okay. I have the equation y is equal to a sine omega t, like that we have. Okay, how I am going to check this dimension is correct or wrong? Y is a displacement. Okay, actually it's a displacement equation. It is meter. A is the amplitude, which is meter. Okay, sine. What is omega t? Omega is the angular velocity. Okay, angular velocity is equal to angular displacement by time. So omega t is equal to theta. Actually it is a theta, sine theta. It is correct only. Theta we don't have dimension formula. These two together we don't have dimension formula. So L is equal to L. This is dimensionally it is the correct. Okay. So now we proved this two is dimensionally correct. Okay. Then we are going to do with the next equation. How can you derive induction? Yeah, I'll do it. Induction, calorimetry, everything I'll do it. Everything I'll do it. But I'll complete this. Okay, you can send me in a message. Okay, so I'll do it definitely. Can you explain the calorie? Can you explain calorie? Yeah, yes, definitely. Derive inductance. Yeah, I'll do it. Inductance, I'll do it. Okay, I'll do it now. Yeah, calories also I'll do it. Okay. Now, calorie. Okay. So, what is calorie? So, calorie is a 4.2 exact value 4.2 joules. Okay. What is kilocalorie? Kilocalorie. It's going to be 4,200 joules. Okay. Now, I'll be explaining what is calorie and kilocalorie. Okay. So, some of them you asked, and also inductance also I'm going to do it now. Okay. So, calorie is the 1 gram of substance. How much heat energy can be required to rise the 1 degree Celsius? We have 1 gram of substance, some X substance. Okay. 1 gram of substance. How much heat energy is required to rise the 1 degree Celsius? We are taking as a calorie. That is a water. Okay. Why we are taking as a water as a reference? Because it's available everywhere. Okay. Kilocalorie. 1000 gram. That's going to be 1 kg of water. How much heat energy is required to rise the 1 degree Celsius? That we can take it as a kilocalorie. Okay. Next I am going to do with the inductance. Okay, whether it's a self-inductance or mutual induction, we can take it as a Henry. Okay, that also I am going to do it now. Okay, inductance I am going to do now. See how I am going to do with the inductance. Okay, I will do with inductance. So mutual inductions are self-inductance, which is going to be, so I'll write the equation. M is equal to EMF divided by di by dt. Actually, this equation EMF is equal to M times of di by dt. Like that we can write. Otherwise, L times of di by dt. M is for mutual induction, L is for self-induction. Okay. So, L is equal to EMF divided by di by dt. Okay, it is the final formula for inductance. Okay, so inductance we can call Henry, EMF we can call voltage, current we can take it as ampere, time we can take it as a second. Denominator directly will go into the numerator. So unit will be volt second by ampere. Okay, now how I am going to solve this unit? Actually, self-inductance or mutual induction, both we can call is the same unit. Voltage is going to be work done per unit charge. Work done per unit charge. And into time, it's going to be the second, and denominator is the current, which is going to be the ampere. It's only for what is work done. Work done is equal to joule per coulombs. So joule per coulombs second into ampere. Like that we can write as the unit. Joules I know it's going to be Newton meter. So Newton meter second by coulombs into ampere. Like that we can write as the unit. Okay, Newton, what is Newton? So we can write as a kg meter second minus 2 into meter second divided by coulombs into ampere. I'll write here what I wrote there. Okay. So Newton, it is a force unit. Okay. So force we can write as a kg meter second minus 2. And we have meter, then we have second. Okay, divided by coulombs. Coulombs already I told you. Coulombs we don't have dimension formula. We can write this the coulombs as the ampere into second. Okay, into ampere. Because of this coulombs, I wrote ampere into second. Ampere square. Okay. So kg meter square second minus 2 plus 1. Okay. So we'll have minus 2 plus 1, we'll have minus 1. Okay. Ampere square second minus 1. Okay. Sorry, second plus 1. So now kg meter square second minus 1. From denominator, if you are taking as this as a numerator, ampere minus 2, second minus 1. So minus will get as a minus 2. So kg meter square second minus 2 ampere minus 2. Dimensional formula for this m L power 2 t power minus 2 a power minus 2. So it is a dimensional formula for one entry. Okay. Next we will be doing with uses of dimensional formula. Now we are doing, we completed as a first uses. We can identify whether its equation is dimensionally correct or wrong. Okay, we can, using of dimensional formula, we can find it, the equation is dimensionally correct or wrong. Okay, next we are going to do with second uses. Okay, we can derive the relation among the physical quantities. Okay, so see here how I am going to derive the relation among the physical quantities. Okay, it's very simple. Okay, second uses I am going to do now. Okay, third uses we can convert from one system to another system. Okay, now I am doing with uses of dimensional formula. Okay. Second uses, first uses, we can find the homogeneity of the equation that already I given 2-3 examples. Okay, next we can find the relation among the physical quantities. The most famous formula T is equal to 2 pi root of L by G. This equation only we are going to prove using of dimensional formula. Okay, we have the simple pendulum. The length of the pendulum I am taken L. The mass of the pendulum I am taken M. Okay, time taken for the pendulum I am taken as a T. Okay, we are going to calculate as the T. The gravity also going to act G. Okay, so T is directly proportional to mass, length, time. Okay, I don't gravity. Okay, so time period is basically depend on these three quantities. Okay, I am given A, B, C. X, Y, Z also we can take it. Okay, X, Y, Z also we can take it. Okay, when we are removing the directly proportional, we can write the constant. So M power X, L power Y, G power, it is M power X, L power Y, G power Z. Okay, so now I am going to write with the dimensional formula. M is for mass, so mass we can write capital M, X. Length is for L, capital L, Y. What about the acceleration due to gravity? Acceleration due to gravity we can take it as a meter by second square. Okay, meter by second square. Acceleration due to gravity is going to be the meter per second square, which already we know. Okay, it's going to be the power of Z. What about this side? Only time is there, time power 1. Okay, mass power 0, length power 0, time power 1, left hand side. Okay, right hand side, K is the constant. Okay, constant is going to be 1, 2 pi. Okay, so M power X, L power Y. Okay, So this is L, this is T. So L T minus 2. Okay, from denominator if you are taken as numerator minus 2, the power will be Z. Okay, so this side m power 0, L power 0, T power plus 1. This side will be m power x, L power y. Here k will be there. Okay, so L power Z, T power minus 2Z, because this is that I am bringing inside. Okay, now L separately, T separately I am going to write. Okay, so m power 0, L power 0, T power 1, which is left hand side. Right hand side, m power x, k times of m power x, L power, see here, y plus z. Okay, then T power minus 2Z we have. Okay, now I am going to equal. So base is same, is same, x is equal to 0. Then base is same, y plus z is equal to 0. Then time 2, z is equal to 1. Like that we have. Okay, just a comparison with one base to another base. It's very simple. Okay, now what is going to happen? X is 0, okay, y is minus z. So now we are doing application of dimensional formula. Okay, first application it is used to find checking dimensionally the equation is correct or wrong. Okay, second one, we can find the relation among the physical quantities. So second application of the dimensional formula. Okay, so y is equal to minus z. Okay, third formula I have like this, minus 2z is equal to 1, z is equal to minus 1 by 2. I got z is equal to minus 1 by 2. What about y? Y is equal to minus z. So minus of minus 1 by 2, which is going to be y is equal to plus 1 by 2, I'll get. So y is equal to plus 1 by 2, z is equal to minus 1 by 2. Okay, and x is equal to 0. How I got this? Left hand side, right hand side, just I am comparing using of dimensional formula. Okay, now I am going to do with the solution. See here, so this everything right now no need. Okay, now time period. Time period is equal to k times of mass power 0. There is no mass power, x power will be 0. L power, what is L? L power y, it's going to be plus 1 by 2. What is G? G power minus 1 by 2. Okay, it's very simple. Now I am taken as a minus 1 by 2 as a denominator, which is going to become as a plus 1 by 2. Okay, so T is equal to k m power 0. It is plus 1 by 2, we can have root 2, root L. It is minus 1 by 2, denominator if you are taken, it's going to be plus 1 by 2. That's going to be root. Okay, T is equal to, m power 0 will be 1, root of L divided by root of G. So, T is equal to k times of root of L by G. What is K? K is going to be here, it is a 2 pi. Okay, so finally we got time period is equal to 2 pi root of L by G. It is a second uses we form. Okay, so dimensionally, using of dimensional formula, we derived this equation. Okay, so using its second uses to derive the relationship among the physical quantities. Okay, the limitation of dimensional formula you are not able to do with the constant term. Okay, and the relations also you are not able to derive using of this method. Okay, third uses we are going to convert from one unit to another unit. Now we are going to do with the third uses. Please wait 1 minute, I'll come back. Okay, third uses. So uses of dimensional formula, we can convert from one unit to another unit. Just see what's going to happen. Conversion of one unit to another unit. Okay, here we have SI unit, here we have CGS unit. Okay. So here kilogram, so M, L, T, M1, L1, T1. It's going to be 1 kg, 1 meter, 1 second. Okay, in kilogram, the same thing M2, which is going to be 1 gram, L2, which is going to be 1 centimeter, T2, which is going to be 1 second. Okay, in SI unit, force I am taken Newton, CGS unit, force I am taken as a dyne. Now I am going to find the relation between Newton and dyne. Okay, so using of dimensional formula. Already I know 1 Newton is how many dyne? 1 Newton is kg meter second minus 2. First I will do the relation, then I will apply the dimensional formula. Then only you are able to understand clearly how I can relate with one unit to another unit. So this is called Newton. So I am converting as a dyne. 1 kilogram is how many gram? 100,000 gram. Okay. 1 centimeter is 1 meter is 100 centimeters second minus 2. Okay. Now 1, 2, 3, 4, 5 zeros. So 10 power plus 5. This everything we can call Newton. This everything we can call dyne. Okay. So 1 Newton is 10 power plus dyne plus 5 dyne. Okay. Now I am going to use a dimensional formula to find 1 Newton is dash dyne. Okay. It's very important concept. It's one of the application of dimensional formula. Okay. So left hand side N1 Newton, M1, L1, T1. Right hand side N2. Okay. M2, L2, T2. Okay. Now one unit to another unit we are going to calculate. Okay. See what I am going to do it. This I am bringing as a denominator. So it is x, y, z. X, y, z. I'll do here. So I'll do here. So already we found 1 Newton is 10 power plus 5 dyne. Okay, that's only I'm going to prove. I'm going to convert from one unit to another unit. Okay. So m power 1 x, L power 1 y, t power 1 z is equal to it is n1. Okay. Then n2 is going to be, it's Newton, it is dyne. M2, L2, T2. Okay, the same x, y, z. Same x, y, z. Okay, I am making together. Okay, this I am bringing as a denominator. So I am finding what is dyne. Okay, how many dyne? Okay, so n1 that's going to be the Newton. M1 divided by M2, which is going to be power of x. L1 divided by L2, which is the power of y. Okay. T1 divided by T2, which is the power of Z. Okay. Now M1 is how much? 1 kg. M2 is 1 gram. 1 meter, 1 centimeter, 1 second, 1 second. Okay. So see here what I am going to do it. So 1 kg divided by 1 kg divided by 1 gram. Okay. Then 1 meter divided by 1 meter divided by 1 centimeter. Okay. 1 second divided by 1 second. The power will be x here, y here, z here. Okay, is equal to, we are converting as a dyne. How many dynes? Okay, so 1 kilogram is how many gram? 1000 gram. Okay, so just I am writing as a 1000 gram by 1 gram. The unit will get cancelled. The power will be x. Okay, 1 meter is how many centimeter? 100 centimeter divided by centimeter. Centimeter get cancelled. Power will be y. Second can cancel 1 z. Okay, now what is x, what is y, what is z? Okay, the dimensional formula for Newton. Newton is equal to kg meter second minus 2. M power 1, L power 2, L power 1, T power minus 2. So M power x, L power y, T power minus T power z. Okay, that means what is x? X is equal to 1. What is y? Y is equal to 1. What is z? Z is equal to minus 2. So x is equal to 1, y is equal to 1, z is equal to minus 2. Well, it's very simple. Just I am going to substitute. N2 we are finding. Actually, dyne we are finding. Okay. So it is 1000 power 1 x. Okay. 100 power y power 1. Okay. 1 power minus 2 z. Okay. So this is going to be 10 power 5. Already I told you the relation among these two is going to be the 10 power 5. So 1 Newton is 10 power plus 5 dyne. Okay, that only be found using of dimensional analysis. Okay. Second, same way you can find Joule to ERG also. Okay, the same method we can use it. Okay, that also I am going to do it now. It is a third application we are doing for SI units and measurement. Okay, dimensional formula, third uses we are doing. Same method I am going to use to find the Joules to ERG. Okay, this method is very important. Okay, so Joules to ERG. First we will have the relation Joule is kg meter second minus 2 into meter, because Joules is Newton meter. So kg meter square second minus 2. This we can call Joules. Okay, the equivalent unit ERG unit. 1 kilogram is how many gram? 1000 gram. 1 meter is how many centimeter? 100 centimeter. Okay, because of meter square we have square here. So gram centimeter square, and the second will be second only, second minus 2. Second minus 2. Okay, so 1000 into it is 100 square, we'll get 10 power plus 4. Okay, here it's 3, so 10 power plus 7. Okay, so this everything we can call as a Joules. This everything we can call as a ERG. Okay, 1 Joule is 10 power plus 7 ERG. Okay, using of dimensional analysis method, I am going to convert from Joules to ERG. Okay, so see here how I am going to do it. First we will find dimensional formula for this. Okay, m power 1, l power 2, t power minus 2. X is 1, y is 2, z is minus 2. Easily we will calculate. Okay, so now we will come to know all three values x, y, z. Now conversion. Okay, SI unit. N1 is joules, M1 is 1 kg, L2 is L1 is 1 meter, T1 is 1 second. Why I am writing like this? Because it follows MK system, meter kilogram seconds. Okay, the next one CGS system, centimeter gram second. Okay, N2, which is going to call ERG. This is joules. Okay, M2 is going to be 1 gram. L2 is going to be 1 centimeter. What is T2? T2 is going to be 1 second. Okay, now we are going to convert from SI to the CGS. That's what we are going to do. Okay, same method. Okay, so I think I don't want this one. Okay, but this I want, X value, Y value, Z value I want. Just a comparison. N1, M1, L1, T1 is equal to N2, M2, L2, T2. I want this. This is called ERG in CGS system. This you can bring as a denominator, X, Y, Z, X, Y, Z. Okay, so M power 1 divided by M2 power X, L1 divided by L2 power Y, T1 divided by T2 power Z is equal to N2. N2 will be the ERG calculation. Okay, so we are calculating what is, how many ERG will be there. Okay, so now what is M1? 1 kg. 1 kg. What is M? 1 gram. What is X? Power value X will be 1. L1 is 1 meter. L2 is 1 centimeter. What is power? Power will be 2, because Y power will be 2. T1 is 1 second. T2 is 1 second. How much power will be? Square. The answer will be N2. Okay. Now we will be doing with solution. 1 kilogram is how many gram? So 1000 gram. 1 meter is how many centimeter? 100 centimeters. So 1000 gram by gram. Gram get cancelled. The power will be 1. 1 meter is 100 centimeter by centimeter, but here we will get as a square. Okay. Second by second get cancelled. We will have 1. 1 power minus 2. Okay. We are calculating second unit. This one, ERG. Okay. How many ERG? So this we have 10 power 3 plus 3. Okay, because of 1. This 100 into 100 will have 10 power plus 4 is equal to N2. That's going to be 10 power plus 7 is equal to N2. So already I told you, so 10 power plus 7 ERG is going to be the 1 joules. Okay. So we learned three uses of the dimensional analysis. The first uses, it's going to be finding the homogeneity of the equation. Okay, the second use is deriving the relationship among the physical quantities. The third use, okay, we can convert from one unit to another unit. Okay, so we did all the uses. Okay, now we'll see limitation. Okay, this method is not going to give information about the dimensionless constant. Okay, so it's not going to give any value, anything about the dimensionless constant, the value which doesn't have dimension. There is no dimension means it's not going to give the information. Okay, and also it's not going to give any of the unknown variable like new term x, y, z, like that. Unknown variable is not going to give. Okay, only noun variable, using of noun variable we can calculate. Okay, the another thing, more than 3 quantities is there means it's very difficult to identify. Okay, this method cannot be applied if the quantities depend on the trigonometry function. Okay, in case it's depend on the trigonometry function, it's not applicable. Okay, so we have limitations also for dimensional analysis. Okay, now we are going to calculate with the errors. Okay, so types of error, how we can calculate. First, addition, multiplication, subtraction and divisions about the errors. Okay, first we will do addition of 2 errors. Error calculation we are going to do now. Error addition, error multiplication, error subtraction, error division. Okay, this we are going to do now. Okay, first addition. Addition of 2 numbers, how I am going to calculate with the errors. If in case I am adding with 2 numbers, how I am going to calculate with the error. Okay, so we will take it z is equal to x plus y. Z is equal to x plus y. 2 number just we are going to add. Okay, so how I am going to calculate with the errors, that's the question we are going to do. Okay, see here, its total value also have error, some error. Del z is going to be the error. If example, we have perimeter of this square. Okay, so it's going to be L1, L2, L3, L4. Just we are adding all the values. Okay, so if each value has small error, when you are adding all the 4 quantities, we will get as the total error. The same kind. So when we are adding 2 numbers, okay, x have error plus or minus. It may be plus or minus. Okay, then addition, y also having error plus or minus. It is a plus error. Okay, so I hope you understand. If you are adding x terms and y term, if in case length and breadth, if you are adding, length also have error, breadth also have error. When you are adding together, the total value also will be getting as the error. Okay, so that's the error identification. When we are adding addition, multiplication, subtraction, division, everything we have different calculation. Okay, now I am doing with addition. Okay, there are 2 numbers we are adding. How we can do with the errors? Okay, now z is equal to plus or minus del z. It's a total error. Okay, so x plus y I made it separate. X plus y, which is going to call us the z. Okay, x plus y, which is going to call us the z total value, plus or minus del z, del x, plus or minus del y. Okay, this together will be z. This will be z. Okay, so if you are dividing total equation with z, that will get cancelled. Okay, so see here what I am going to do. It is going to be z plus or minus del z. Okay, and this going to be z. Okay, and plus or minus del z, del x, plus or minus del y. Whole equation divided by z. Okay, total value. Okay, so totally what I got, mean value. Okay, which is going to be 1 plus or minus del z, which is going to be 1 plus or minus del x, plus or minus del y. So this one will cancel. So when you are adding 2 numbers, just you can add the directly, you can add the errors. Okay, whether it's addition or whether it's a subtraction. Okay, you can directly addition and subtraction will be following in the same thing. Okay, if when you are adding with the 2 numbers, you can directly add with the error. When you are subtracting with the 2 numbers, that time also directly you can add with the 2 numbers. Okay, first we did as the addition, then we are going to do with the like a subtraction. Okay, now we are going to do with the subtraction. When we are subtracting 2 numbers, how we can do with the errors, that's we are going to do now. Error means error caused many reasons. It is temperature, atmosphere and instrument fault, okay, because of the least count, error can be caused with many ways. It's going to be random, okay, it's not in a uniform surface, means we'll get error, okay, random error. Sometime, if example, where some doctors will be measuring the temperature, only they will be using thermometer in particular place to get the temperature, okay. It's not your uniform temperature overall body, okay, that can be rise the errors, okay. So in this method we'll be reducing the errors, it will be minimizing the errors, okay, not fully remove the error, we can minimize the error, okay. The error caused with many ways, okay. So when we are adding two numbers, we can add the errors also. To identify the errors, you can add the errors, separate errors, okay. Now we are going to subtract two numbers, how we can do with the errors. So subtraction, multiplication, division, addition, everything have the error, okay. So now we are calculating in addition how we can minimize the error, okay. For subtraction, how we can minimize the error, how we can do with the error handling, okay, that's only we are discussing now, okay. Now I am going to do with the subtraction of two numbers, okay. So z is equal to x minus 1. Just two number I am subtracting, okay. So z have the error del z, it's a error, z plus or minus, it may be plus, it may be more than that value or less than that value. Y also having the error, x also having the error, it may be plus or minus, small error, okay, it's small value. Y also having the error, del 1. Now I am substituting here, just I am subtracting, z is equal to plus or minus del z, x value, x is the plus or minus del x, y is the plus, it's y plus or minus del y, okay, everything have the error, z is equal to plus or minus del z, x minus y, this I am making together, okay, plus or minus del x, plus or minus del y, okay, this together we can call z is equal to plus or minus del z, this is going to be z plus or minus del x, plus or minus del y, okay, just whole equation divided by z, that's called mean value, okay, true value also we can call, okay. So when we are dividing that number, it is going to be the 1 plus or minus del z is equal to 1 plus or minus del x plus 1 plus or minus del y. So this one get cancelled. When we are subtracting two numbers, that time also error you can add and subtract, okay. The final answer del plus or minus del z, that's total overall error is can be plus or minus del x plus or minus del y. You can add both the errors, okay. When we are subtracting, you can add or subtract both the errors, okay. You can get what is the total errors present in that particular place, okay. The next, multiplication of two numbers. I am going to do with the two numbers multiplication. How I am going to do multiplication of two numbers, okay. See here, z is equal to x into y. Z have the error, it's plus or minus del z. X have the error, plus or minus del x. Y have the error, okay. So it's a multiplication into y plus or minus del y. Like that we have. So z plus or minus del z, okay. It is x and y multiplication, xy, okay, plus x times of y. So x times of del y. It's going to be plus or minus because plus or minus is there. Plus y times of del x, y times of del x. It's going to be plus or minus. Okay, then this two multiplication, plus or minus del x, del y. Okay, now we'll see what is going to happen. Del x, del y. It is when we are multiplying with two small least value, the answer will become as negligible. In case multiplying with 0.1 into 0.01, the answer will be negligible. That means this will be negligible. No need to show in a next step. Okay, so then we have like this. So z is equal to plus or minus del z is equal to xy plus or minus. So this is going to be x del y plus or minus y del x. Okay, so whole equation divided by z. Okay, when we are dividing with the whole equation divided by z, so total value. So what we can get here, 1 plus or minus del z by z. I think in previous class, previous concept I left that term. So this is going to be z is equal to xy. This is going to be 1 plus or minus. Okay, x del y divided by z. Z is going to be xy. Okay, plus or minus y del x divided by xy because z is going to be xy. So x get cancel. Okay, y get cancel. Okay, this one get cancelled. When we are multiplying the two numbers, okay, that time also error can be added. Okay, not only multiplication, division of two numbers also you can add the errors. Okay, the concept will come to know when we are adding two numbers, subtracting two numbers, multiplying two numbers, dividing two numbers, error directly you can add. That's the conclusion we came. Okay, division I'm not going to do now. Okay, now the final answer del z by z is equal to plus or minus del y by y plus or minus del x by x. This is error when we get as a multiplication of two numbers. Okay. So now we'll be doing what are the errors will be the instrumental error, enrollmental error, error due to the observer, error due to the imperfection technique. Okay. So I'll do it one by one. Instrumental error. If the instrument is manufacturing defect is there, okay, that means we'll get the error. Okay. So that is a one type of error. Another one is the environment error. Okay, atmospheric error. Today temperature will be 30, tomorrow will be 32, yesterday will be, day after tomorrow will be 28. The temperature fluctuation, atmospheric pressure changes. Okay, this and all will be cause the error. Okay, third one, error due to the observer. Because of parallax method, okay, if you are looking with this eye and the distance between the two eye also can be caused the error. That's also, it's all depend on the observer. If you are, some person will be standing with 90 degree and looking, observing the reading, okay, some person will be standing with some other degree and observing the reading, okay, that also will be caused the error. Okay, and imperfection in technique, they are not following as a proper technique. If example, for measuring temperature, they will be use thermometer in the mouth to measure the temperature, but actually it's not going to show your overall temperature, only the temperature we are measuring as a maximum place. Okay, so that also can be caused the error. Okay, the another thing, the another type of method with error will be totally it's a random error, like it can be caused with anything. Okay, it's atmosphere or nature temperature or surface, it can be caused by anything. Now we'll be seeing what is a maximum maximum possibilities to minimize the error. Okay, so we can minimize the error using of like a high quality machines, instrument we can use it. Okay, in case if you are using one ruler, okay, it's broken some 5 centimeter, okay, you can subtract that 5 centimeter to take the reading. That's going to give the it's going to be reduce the error. If example, your thermometer room temperature is showing 37, instead of 32 it's showing 37, that means 5 degree you have error. That 5 degree you can subtract. Okay, that also will give the correct value. Okay, another thing, imperfection of the technique. Okay, so you can take it the measurement with 2-3 possibilities. Okay, mean value of that you can take it, that will be reduced the error. That is another technique to reduce the error. Okay, so otherwise 2-3% they can take with the different days, they can do it like that to reduce the random error. Okay, the same experiment they can do with the different places or different surfaces, it's going to be caused the reduce the error. Okay, these are the techniques we can use to reduce the errors or minimize the error. Okay, actually we are not completely reduce the error, we can minimize the errors. Okay, now okay, now we are going to do with what is a true value, okay, what is a relative error, what is absolute error. These are the concept we are going to discuss now. Okay, a percentage, there are 4 concepts we are going to discuss. One is the true value, another one is the relative error, another one is the absolute error, another one is the percentage of the error. Okay, these are the 4 concepts we are going to do. Okay, we have the number A1, A2, A3, A4, A5. I have 5 readings. Okay, I have 5 readings. Okay, everything has small errors. Okay, so how I am going to reduce the error? So this is a technique it used to find the how to minimize the error. Okay, so I am taken average of this value. Average of this value A1 plus A2 plus A3 plus A4 plus A5. Average of this value will give the true value. Okay, true value. That's going to be the average of this value. So average value. Okay, we will take it as a mean, a mean. Okay, a mean is going to be the true value. Okay, true value minus each value. So a1 minus a mean, a2 minus a mean, a3 minus a mean, a4 minus a mean, a5 minus a mean. True value minus individual value will give error in the first one, error in the second one, error in the third one, error will be fourth one, error will be fifth one. Okay, so I got the separate error. Okay, now I am going to do with what is some absolute error. The mean of this all the errors is going to be the absolute error. Okay, absolute error. Okay, then relative error also is there. The mean of this del a1 plus del a2 plus del a2 a3 plus del a4 plus del a5. So divided by 5. I am taken mean of overall individual error. That's going to give us the absolute error. Okay, so absolute error we have like this. Okay, so that's going to be del A mean. Before we got A mean. Now del A mean. Error average value. Okay, so now this is called absolute error. Okay, absolute error divided by true value. That's called mean value. So we'll get as a relative error. Okay, this is going to be the relative error. Relative error into 100 will get us the percentage of the error. Okay, if you want percentage of the error, it's going to be the relative error into 100. Okay, upcoming days I will do the problem with all the types of error. Okay, now I am going to do with the small problem based on the error. Okay. So one small concept. We have z is equal to a square, like that we have. Okay. So how I can do with this? So a square we can write a into a. Total error I am going to do. Z have error, a have error, separate error. Okay. So del z by z, error of a total value is equal to plus or minus del a by a. Multiplication also error you should add del a by a. When we are adding this two, it's plus or minus 2 times of del a by a. Del a by del z by z plus or minus. Okay, the power it comes to the when the squaring of some value, no, square, cube, or power times of 4. Okay, that is the time you can write that number as in front of the value, original value. Okay, see here I have another example. Z is equal to a square b cube c power 3 and d power 1 by 2, like that we have. Okay, how I am going to do with the error? Okay, a is 1%, b is 2%, c is 3%, d is 4% error. Okay, so overall error how I can calculate del z by z plus or minus. Okay, is equal to a is going to be plus or minus, square is 2 times 2 del a by a. Okay, b is 3 times plus or minus 3 del b by b plus or minus. Division also same, addition, division, subtraction, everything. Only where whatever power is there you can write in the front. Okay, division also same, 3 del c by c. Okay, plus or minus. So 1 by 2 also is there, 1 by 2 del d by d. What is this value? Del a by a, it is 1% error. I am given, okay, the value 1%. So we'll calculate here what is the error. Small problem for finding the error. Okay, it's going to be plus or minus 2%, because 1 into 2 will be 2. Okay, b will be 2% plus or minus 6%, because 2 into 3 will be 6. C will be 3%, 3 into 3 will be plus or minus 9% will be there. What is D? D will be 4%. Okay, this get cancelled. So 2%. Okay, 2 plus 6 plus 9 plus 2. So 15, 19% as well. Okay, like that you can do with the error calculation. Thank you. We'll see tomorrow class. Bye bye. Yeah, good morning. Good morning, Pa. Calorie sums. Yeah, good morning, everyone. Thank you. Bye bye. We'll see tomorrow. Bye. Bye, Kumari. Bye. Thank you. Thank you. Bye bye. Are you understand? Are you able to understand? So every day morning 10 a.m. We can have 11th concept, 9 a.m. 12th concept. Yeah, thank you. Thank you. Thank you. Bye bye.